We are on live. Cool. So yeah, hi guys. This is Chris from DoraHacks. Welcome everyone to join the opening ceremony of Sway Summer Hackathon. Um, it's such a great honor for me to be the mode of this opening ceremony, and we are super pleasure to have Mr. Nick, the CEO of Fuel Labs, to join us as a speaker as well. So in the next 45 minutes to 60 minutes time, Nick and I will provide a high-level intro about this hackathon, including the background, the vision behind the hackathon, all of the tracks, and of course, I assume Nick will introduce a bit more about what is Fuel, although I assume that many people have already known about it quite well. I will also work through the platform of DoraHacks, which is going to be the main hub for developers to submit the project to the hackathon. Give a very quick demo about like how developers can do that. And in the end, we will have a very short Q&A if there's any. So yeah, Nick, feel free to start.
Awesome. And how much time do you think I have just to present, just so I can just tailor it a little bit? Because I know we want to probably keep this to what, like in total, an hour, something like that.
Yeah, the maximum time will be 1 hour.
Okay, and that's for both of us. And then on my side, what do you think is
so we
appropriate?
can, yeah. So I think we can left like 5 minutes for Q&A, and my part can be like very short. It's quite simple. So
Okay.
you can take as many as you want. Yeah.
Okay, great. Yeah, I think my presentation should range between like 30 and 45, so something
Sure.
like that.
Yeah. That
Cool.
works.
Awesome. All right. Well, thanks everyone who's attending, and for all those who are coming to Hack. This is super exciting. For us, I think we're we're really looking forward to seeing what comes of like the next month, and all the hacking that's going to get done on Sway and Fuel. So again, yeah, thanks for joining us here. So today I'd like to just do a presentation, I think, to help kind of center and ground us a little bit into, I think the importance of blockchain, and where, Fuel sits into that picture, and just where the space is progressing, and, hopefully provide people with some useful information as they start thinking about what they're, going to hack on, and as well, I think just sort of the, where the space is trending, and where I think the future lies for blockchain itself. So yeah, to start off today, I think the agenda will just cover three core topics. So the first is just why blockchain, just to start it off, and then where is blockchain architecture headed, and the last piece is really sort of the Fuel stack and going through Fuel side of this picture. I'm gonna not go too far into what is blockchain in this presentation, because I sort of assume people have a pretty decent understanding, even though we'll cover some core topics. But this is more about just kind of getting into the trajectory of things. So yeah, to start off, just why blockchain? I think this is a big one, especially as the space takes in all these new kinds of headwinds, and as well AI is really taken off. You want to kind of come back to center and ask yourself this question. So I think just in the next few slides, you'll see some reasons why I think a lot of this is important. So here, Argentina, basically undergoing a full currency collapse, not something that's happened just once, but has been something that's been constant pressure on the country itself, and the people. As well, Lebanon, as of recently, suffering, I think, a lot in terms of their side of currency collapse, and what that means for them. As well, like some pictures here of Venezuela, and just the stuff going on in that country for quite some time, and as well, just looking at some kind of these major institutions in the world, and both where and how they're allocating capital, and also just the shortcomings of having a small group of people, I think, dictate a lot of the the world's money, and in a sense, a lot of the power of the world. And then coming back to to ground a little bit, the crash of 2008, which really kind of was one of the key predecessors of pushing forward this concept of blockchain and of course Bitcoin itself. So I think looking at what's happened over the past while and just looking at the shortcomings of humans, I think blockchain and Bitcoin is really something that just to always come back to this genesis block. The Times, January 2009, Chancellor on brink of second bailout, for banks. I think it's important to recognize that, out of all of the degeneracy and crazy things in the space, that, a lot of this started because there are some pretty significant institutional failures happening. And, we as sort of engineers can maybe make a bit of a stand and also, build towards a different kind of future. So, when we're coming into the question of sort of why blockchain, I think the above really highlights it. And, the way that I think I and Fuel see it is, systems of high trust can be broken by human shortcomings. And namely, human institutions can continue to fail us by greed or complacency. And I think that this is really the stem of a large problem that blockchain aims to address. Some examples are banking failure, corporate greed, and as well just government financial mismanagement. And I think that these are areas that are continual issues and things that blockchain I think hopes to open up a little bit. The solution of blockchain is really to say that through engineering and economics, we can build these sort of trust minimized systems and fault tolerant systems, ones that are harder to break by the shortcomings of humans, and systems to aid humans in their pursuit of just a better world. And I think that blockchain in many ways is really here to aim at this and to try to move that case forward. And so looking at just blockchain itself and what makes it sort of above other human protocols, some key things to look out for are censorship resistance, trust minimization, and fault tolerance. And so when a system has these kind of three requirements, I think it starts to inherit a different kind of metaphysical status to humans, and this is where it kind of transforms a little bit and becomes something I think really fascinating. So to look at these kind of properties a little further, and kind of how they're built into blockchain, really blockchains enable us to kind of get some of these properties out of a system. Censorship resistance really sort of more on the ideologically driven side, where people now with blockchain can run software that have this belief of censorship resistance, to having a globally accessible system and one that is just going to be there for other human beings. And I think this is an extremely powerful property of blockchain and one that gives it a very kind of special property. As well, trust minimization. So cryptographic proofs enable us to design systems that aren't reliant on human verification alone. And I think this is another key property that we can build these engineered systems with cryptographic proofing and mathematical proofing, and this allows us to get out of this realm of humans really going in there and supporting and verifying a system. It can be a system that's really supported by math, and that allows us to, I think, again, achieve that kind of property in this sort of system. As well, fault tolerance. So we can design systems to be peer-to-peer and global. We can give them consensus rules, and this reduces the amount of maliciousness and accidental failure that may happen from any particular party. So these are three sort of the way I see three key properties of blockchains that you do want to try to carry through in your architecture. So to give like a little rough history, in the 90s up until around 2009, you had a lot of cypherpunks and cryptographers talking about eCash and Hashcash and Merkle trees and smart contracts. There was a lot of discussion, but in 2009 we kind of had our breakthrough, and that's really Bitcoin, and really just kind of giving us this concept of blockchain itself. Of course, in 2014, Ethereum coming to be and giving us this idea that I think these systems can be really used for fully fledged applications, but are unfortunately the Ethereum system is very constrained at scale, and this is really a big issue. And then in 2019, you have kind of rollups and modular chains being discovered as a concept, and really scalability for all blockchains is a potential pathway. And in 2020 was when we deployed our first rollup to mainnet, Fuel V1, and that's really where Fuel's journey begins in this kind of picture. To take a step back, I think it's also useful to take a look at some of the ideological side of the use cases of crypto, and also just the commercial ones. And really, the commercial ones play off of a lot of the ideology, but as well, the ideological ones cannot really be achieved without a lot of commercial success either. And so both sides here play off of each other. And I think it's just important to reference that. But to go through some of the ideological side of this, you really have, value preservation as a key one, free expression, financial freedom, privacy and voting, and finance as well, freedom of assembly. So, building your own kinds of communities that have their own support systems, and as well, just like more transparent finance. And so these are some examples of some of the ideological sides of blockchain's use case. On the other side, you kind of have the commercial setting, and that's really things like value transfer, so B2B and B2C, value preservation again, which does have a lot of commercial purpose, exchanging payments, incentive systems, virtual goods and services, access control agreements, notarization, identity, points and rewards, metaverse, virtual worlds, reserve currency, just to hold, etc. So, really important to note that blockchains are actually quite good at a lot of these things, and as much as people might have you believe the other story, they're actually excellent for it. It's just we want to achieve a reality where people can actually get to an accessible stage for this. But again, it's useful to note that you can't have one or the other. They both play off each other, and it's what makes blockchain so special here. In looking at just the sort of progression of blockchain over the past little while, you have starting off with Bitcoin, and just getting into your basics of proof of work and Nakamoto consensus, etc. Then moving into Ethereum, where you're really progressing the core ideas, and moving beyond just like Bitcoin script and getting into more general purpose applications. There was quite a period of time where I think a lot of people were experimenting with sharding, things like Lightning, state channels, and side chains, pushing for better security. But I think that they lacked a lot of guarantees, and people were just pretty unsure, of that pathway. And then naturally, you have rollups and modular chains coming that establish, I would say, a better separation of concerns, which again achieve more scale while retaining the sort of security properties we're looking for. And that's really that final breakthrough. So blockchains are really getting better. They're enabling more useful features while retaining security at scale. So this is really an important piece to the story. So an image that some of you may be more familiar with is just kind of looking at blockchain through a lens of breaking up some of the concerns of what's happening. And this is just more in the internal processing of blockchains themselves. So you can see that, like, you have things like execution, which is the verification of transactions, settlement, which is really, you can break up into sort of dispute resolution. So the final layer of which things are going to settle, and bridging, consensus as well. So just the ordering and agreement on transactions, and data availability. So ensuring that the transaction data is available. And so, the top two really are very experiential in the sense of, where the currencies are going to be bridged from, where dispute resolution is going to happen, and also how transactions are going to be verified in the system. And ultimately, that's going to have a pretty massive impact on the final experience you're going to have. And then on the security side, more into consensus and data availability, where you're really looking at the other side of the puzzle, which is really just trying to ensure that the data is available, and trying to ensure that there's consensus and agreement upon the ordering of that transaction data. So, coming from the, this world where all of these things, are bonded together in a system, like Bitcoin or Ethereum, only up until recently starting to split off with rollups. You're kind of looking at a separation of concerns here into, execution, settlement, consensus, and data availability. And this is really stemming into this whole conversation about rollups. And so, on the spectrum towards more modular designs, this is an image source from some people at Visa. They did a great job describing some of this stuff. We're moving from, I'd say, monolithic design patterns and monolithic models all the way over into, a space where there's more modular chains and modular compartmentalization of things. And through a lot of experimentation, I think we've seen some really interesting work done in side chains, and also just having alternate forms of bridging and security. But really, now we're moving towards a more roll-up focused future as a key scalability pathway for larger chains, particularly Ethereum. And some interesting things to note too are just, and this isn't entirely accurate in terms of a blockchain may have different orders of how it's actually going to process some of these things, but the key components are here, which is really looking at the transaction lifecycle. And so, blockchains are inherently transactional, and you're making transactions in the system. And so, when you're looking at how we originally constructed blockchains, you kind of had block producers do all functions of this sort of system. And you would have a transaction move through a mempool, would then be ordered and executed. Of course, there's different ways of which you can accomplish this. Then you would have sort of the storage and final settlements and things like that. And so, in this way, you can kind of look at this as a very monolithic transaction lifecycle. But as you move into thinking about things in a more compartmentalized way, and in the roll-up headspace, there's some interesting opportunities to kind of break things up. So on the mempool and ordering level, you can really have sort of a sequencing layer. On the execution side, you can have a roll-up execution piece, which is again going to take care of transaction validity and sort of building out what the context and the state of a roll-up is. You can have different layers do data availability, and then finally you can have a roll-up executor that's going to push to a specific settlement layer. So someone's going to push data, say something like Ethereum. So in this case, you can kind of look at this as a more modular transaction lifecycle, where you have a bunch of different parties, not just two, involved in sort of the processing of a transaction. As well with rollups, another keynote is design patterns like this, where you're going to have things like forced transaction inclusion, where basically users can force transactions in and kind of bypass some of these settings and some of these systems. And this is really important to create things like exit doors for rollups themselves. So this is again just to note some of the transaction lifecycle and kind of looking at blockchain from this perspective. So some different ways to look at rollups and blockchains right now. You have a more Ethereum-centric way to look at it. So that's going to be, basically layer 2s and layer 1s. And then at the very bottom, obviously, just like the social consensus of the community and those running, the technology themselves. And then you have the more, modular-centric view, which is really looking at the different concerns, execution, settlement, consensus, and data availability. And so, these two ways of kind of looking at the layers of blockchain are really important to understand. I think just the progression and where things are headed. We're really looking to get more and more granular, and I think the separation of concerns is becoming more and more interesting as the space progresses. We're moving further and further away from having a single chain do everything to having many, many rollups do a lot of different things. So ultimately, looking at the space and the progression of kind of where blockchain is headed, we're moving more towards a space where we're compartmentalizing more. And this is actually giving us a lot better properties of scale. And so, you look at why modular is better. Well, because there's, key separation of concerns. There's specialization that's going to come with that. So different parties can specialize on different things and more appropriately price them. And ultimately, that's going to give you better scalability properties. The last key thing to note is that as you separate concerns, you're also going to achieve another interesting property, which is more opportunities to scale out or horizontal scale. And so this is going to allow you to really supercharge the amount of scaling you get, because the more nodes you add or the more computers you add, basically the more scale you can achieve. But you can really only do this when you have things like proper scalability techniques in mind, and you really do separate the concerns out for blockchain processing. So I'm sure many of you have seen this image before. And effectively, this is just looking at the various concerns of blockchain sort of as we know it, and really breaking it up into some different ways to think about it in different categories. And the main thing here to look at is just sort of, at least in the context of this hackathon, is where Fuel sits in more of the execution side. And so, I think the kind of core way that we see it is more or less on the rollup and Validium side, where Fuel is really taking this concern of execution. So really how transactions work and how they're going to be validated to hard, and that's really where our focus and specialization is. But as well, there is cases where you could run different configurations in more of the modular centric way, and basically achieve some interesting properties in more of a sovereign rollup. And I think that's also noteworthy. It should also be noted that Fuel can run in most of these settings as well, in even a monolithic setting if you wanted, but it's not really our focus at the moment. So looking at sort of a rollup security perspective, and this is more namely in the Ethereum rollup space. These are some properties that are taken from Layer 2 beat, but I think they really describe what you're looking for in a rollup on Ethereum quite nicely. So, state validation. So how are you effectively validating that these rollups or these systems that are sitting on top of Ethereum or these layer ones, how are you ensuring that each state transition is valid, or how are you catching ones that aren't? So this is really, really important, and ideally you want a system that allows you to catch fraud or prove fraud, and ensure that the rollup is valid through and through. So you really want that as well. You want the data to be very available. So hopefully published on Ethereum or published on a layer that makes data availability a priority. As well, upgradability. If a rollup is going to upgrade or be upgradable, you want to get some good notice on what the upgrades are going to be. The main reason is because you don't want a malicious actor, say, upgrading things and just taking all the money. You want a system where upgradability is going to be known sort of in advance, and you have time to exit in the event that there is an upgrade you don't like, or there's no upgradability altogether. As well, sequencer failure. This is another key piece. So what happens if the main sequencer goes down? Can the chain still continue? Can you still get your funds out? And lastly, the proposer failure. So can I actually propose transactions in the system such that I can actually still get my funds out? Who can propose transactions and in what failure cases? So looking closer to what good looks like in this setting, you want the rollup to be fully validated or fraud provable, either by ZK or optimistic rollups. You want the data to be fully available, so really in a nice setting that anyone can pull from. As well, upgradability. You either want the system to be non-upgradable or upgradable with good fair warning. You also want the sequencer to be able to fail and things to still be able to be fixed or progressed. And then lastly, you want the property of anyone being able to propose in this event, so that they can actually do things like forced transaction inclusion and get their funds out and withdraw them from the layer itself. So these are some really key properties that you're going to look for in what is a really good rollup. So looking at some of the risk analysis, again, pulled from Layer 2 beat, you can kind of see the current bigger players in the space. So Arbitrum, Optimism, ZK Sync, DYDX. and they're kind of various, you know, positions on this scale. And so, really we're moving towards this future where fraud proofs are going to be fully instantiated. We still haven't really achieved that yet with everything, but it is coming. And as well, I think we're moving closer towards a future where we're going to achieve all of these properties with these rollups, but be able to also find a lot more scalability, and that's really where Fuel comes in. So, what does the ultimate rollup look like? So it's not just going to achieve those properties that I mentioned before. There's going to be a bunch of other properties that you're going to want to hit. And this is really where, Fuel's entering the picture a little bit. So on the scalability side, you really do want to have things like parallel transaction execution. You want to be able to use all the resources of the node in the rollup to process transactions. You also want a non-wasteful optimized virtual machine, one that, doesn't waste a lot of processing on things that you don't care about so much. You want something really lean and efficient. You want extensibility, so things that you can add in what are effectively pre-compile like things. This includes adding stuff like just-in-time compiling and those kinds of things into your system, or make that accessible. As well, you want things to be easily deployable. So you want to be able to deploy rollups quickly as well. Just in the event that, say, a single rollup runs out of execution capacity, you can start deploying more rollups. And this also means that you can deploy more rollups and have them bridge together, which is a really important sort of key property. The second area is security, and really, you want the rollup to achieve a very high grade of security. So one that really inherits the base chain. As well, you don't want any magic upgrade keys or an unknown upgrade process. You want that to be really thought out, and as well give users the time to leave if they need to. As well, you want them to be able to withdraw their funds in the event of a sequencer failure. Fully fraud provable is another one. And as well, the sequencer to be decentralized. So you don't want a single server sequencing all your transactions, especially in the cases of more DeFi related stuff. You want another party to help you sequence those transactions and decentralize that process. The last thing is really on the experience side. So, we want to be able to achieve things like account abstraction, gasless transactions, meta transactions, fast pre-confirmation, low bridge times, can be bridged to other chains and rollups easily. You also want reliable and efficient and easy to use tools to build these things. And you probably want to be able to use any modern wallet. So any Ethereum wallet, any Cosmos wallet, any Solana wallet, whatever you're coming from, you want to make sure that that's covered. So these are the properties you're looking for to really get to what good looks like, I'd say, in a rollup setting. In short, you want the rollup to be able to scale vertically. So within itself, you want to have a lot of parallel transaction execution, and also horizontally, in the sense that you want to be able to deploy more of these and have them bridge together. As well, you want to achieve a high grade of security, so inheriting security from things like Ethereum. And as well, you want the experience to be so good that users don't notice they're on a blockchain, and a developer experience you barely feel at all, that you can just focus on your application logic, ship incredible applications to this execution environment, and not really think about all the shortcomings of blockchain. So where Fuel really differentiates from the space, and particularly a lot of what's going on in the EVM space, is the current space really is more of a band-aid approach to progressing the technology and the stack. So when you look at all the solutions that are coming out, and all the different EIPs and things that are progressing the current rollup space, it's really just band-aiding on additional things to help us alleviate certain key problems. And this is a very valid approach, because you need to retain backwards compatibility, but it also really restrains you from what kinds of solutions you can bring to the table. As well, the development of a lot of these systems is very fragmented, both on the scalability side, but also in the developer experience. And lastly, a lot of the designs we see typically in the sort of Ethereum world are very heavily stateful. So they use a lot of state, and with blockchain, state is very expensive, and it just ends up being a lot more to process. And so if you want to make systems more accessible to the world, you really want to reduce the amount of state you're using in a blockchain. So on the Fuel side, we take a different approach where we look at what's the best system we can build, knowing that the past tooling and scalability was done a certain way. So knowing all the past tooling, how things were approached, can we build just the absolutely best system possible? As well, we take a vertically integrated approach where really we're trying to give you a solution where everything works nicely together. This is obviously a big lift initially, and we're still in the process of getting this right. But in the end, the aim is that the developer experience is really smooth and something that really doing it in-house gives you some big advantages. As well, you want to trade off backwards compatibility if you really want to do something different. So for us, we trade off the backwards compatibility, the EVM, for what you actually want, which is really a system that gives you enormous scale, that gives you the kinds of transactional capabilities and properties you're looking for at the native level with no compromises. And as well, lastly, encouraging developers to use better design patterns, ones that are more state minimized. And this again is going to increase the total throughput of what you can process, but also just the total accessibility to your application and what you're building. So state minimized design is really important. So, in terms of looking at improving Ethereum and blockchain, Fuel brings some key things to the table. So again, one of them is parallel transaction execution, being able to use all the threads and cores of your CPU more efficiently, and providing a pathway to better scale and scale out. As well, more efficient and flexible blockchain optimized virtual machine. So a virtual machine that is really designed for, rollups, and also is designed for the kinds of computations we typically see in smart contracts, and giving you the best chance to again make your app as most accessible as possible. Things like native level account abstraction with predicates, as well as support for native level assets. So assets in Fuel are really first class citizens and are done at the base sort of transaction processing level. This gives you a lot more flexibility as to what you can get done in a system and in a blockchain. Flexible scripting is another key piece, as well a more sophisticated language and developer tooling experience, and as well a blockchain that's designed for efficient sort of trust minimized bridging. So one where effectively rollups can be bridged together in such a way that you don't need things like multi-sigs and these multi-sig oriented bridges and stuff like that to be able to bridge funds. You can use very primitive smart contracts on both sides to actually accomplish bridging. So Fuel really aims to bring a powerful sort of alternative to EVM based stacks, but that is still secured and bridged to Ethereum. So really providing devs and the community a different way to do things outside of the EVM, but still really aiming towards this future of scaling Ethereum and scaling blockchain. So you can think about the Fuel VM system, or sorry, just the Fuel system as the Fuel stack. So this is really encompassing a bunch of different key pieces of tooling and infrastructure that work kind of across the various concerns of blockchain. So on the top, you're really going to have the portal and wallets. The portal's still under development, but we did ship the initial version of the Fuel wallet. There, we're going to really push a lot of interesting key management techniques and account abstraction. Right now, it's very basic, but that's where we'll be doing that kind of work. The SDKs, obviously, to interface between your known languages and the Fuel architecture. The Sway smart contract language, so sort of the ultimate blockchain smart contract language that can possibly be constructed. Still have a ways to go, but that's really the aim of the whole system itself. Fork tooling, so this is really an all-in-one place for shipping apps, and eventually we'll be shipping rollups for the Fuel architecture. As well, the Fuel VM, so a really extremely optimized virtual machine for blockchain use cases that also gets to leverage sort of UTXO based transaction models and our native asset system, and give you again a different kind of experience to building on blockchain. And lastly, our client improver. So this will be another key piece of the architecture where you're going to have a flexible client that you can use to configure to various different blockchains, for all different concerns, whether it's settlement or DA, or ordering and the mempool itself. So really, to look at just building apps on Fuel, I think a big and a key approach to think about is more the Fuel native way of building applications, and this is really looking at state minimized design. So Fuel can give you and accomplish all the sort of standard Ethereum stateful contract design that you're used to. So if you're less up to date with some of the more interesting things Fuel brings to the table, you can just go and build apps how you would build them typically on Ethereum. So a little more stateful, smart contracts, the typical way that you've done it with Solidity and Ethereum. But to look at sort of more of the interesting use cases that are more state minimized, it's going to be more of a focus on leveraging things like UTXOs, things like predicates and account abstraction, as well leveraging scripts, leveraging as well just the native level token design that we bring to the table, and as well just clever use of proofing. So Fuel's basically state and receipt system is one that is far more accessible or easier to understand and leverage than Ethereum's. And so, leveraging these systems and building more interesting use cases, I think is sort of what we're looking for. In terms of some ecosystem examples, just to note, so on the left, we have the Fuelet wallet, an awesome wallet for the Fuel ecosystem. As well, Thunder really crushing it with an NFT marketplace. Definitely check that out to sort of see what's possible, on Fuel in terms of the experience. If you're looking for just example code and just good starting points of some working apps on testnet, you can look at Sway Farm. Sway Farm is like a great sort of simple game that's leveraging the beta 3 testnet. As well, Sway Playground, that allows you to build things, Sway smart contracts in browser. You can check out the code for that there and how that all works. These are just notable things to keep an eye out for if you're looking for just some examples, and particularly some beta 3 network examples. To just do some final notes here, on the beta 3 testnet, you're basically going to need to use the beta 3 toolchain if you want to ship to the beta 3 testnet. There's been since then a lot of breaking changes in the more recent updates. So if you're planning to ship to testnet, you're going to have to use some of the older tooling and some of the older SDKs and stuff like that. So just be ready for that in the beta 3 setting. If you do want to use the more latest tools and some of the more later features, then you're going to go more towards the beta 4 RC toolchain and more the recent releases of the SDKs. Just to note that there's no consequences in developing your system locally. Both are totally valid. And just wanted to note that. I would just say with Fuel that really as a project we're looking to bring blockchain to its inevitable conclusion, which is really blockchains that don't feel like blockchains, and creating experiences where we no longer have to even think about blockchain itself, and we can just build the kinds of apps that inherit these really special properties of blockchain, but also give that to regular people and make that accessible to regular people. So happy hacking for everyone, and really excited for everyone to kind of join us over the next month and hacking on Fuel. And yeah, that's wrapping the presentation.
Awesome. Yeah, thank you so much, Nick, for this very detailed introduction about the Fuel. And we are definitely super excited to support. It's actually the very first time that we support Fuel in terms of the developer efforts. And definitely your vision behind align with us. We definitely see the trend that shift from monolithic to modular, which is also why that we are so excited to support Fuel. So yeah, I have seen that audience have asked about the submission process. So I'm gonna give a very quick demo about for audience, just in case that you guys have some issues with the submitting process. So yeah, so here is the main website of DoraHacks, which is gonna be the submission portal for Fuel Hackathon. I think I need to sign out first. Yeah. So as a new users, you can come here, type the DoraHacks.io. There's a button at the very top. You can click Hackathon, and you can see View is highlighted as the page. And you can click the View page here, and you're gonna see like all of the board, the tabs here. Here, the buildos. So buildos means actually projects. It's derived from HODL. So buildos means build, and it's a noun for project. So don't get like confused. It's just like project, and you can see all of the tracks here. And as a developers, when you are trying to submit a project, the first step will be you log in. There's a couple options, and we will recommend GitHub or email, because anyways, in the end of the hackathon, you need to provide your GitHub as the judge criteria. So you can log in first with GitHub here. Just save you some time. So I have logged in before. So here you can see. By the way, there's like couple like language for developers from global. So feel free to choose the best language for you. Let's do it again. And here, as you can see, the hackathon has already started, which means that the portal is open, and there's two options. The first, submit build, means that you can submit a project, and second, register as a hacker. It means that you want to participate in a hackathon, but you haven't officially formed the ideas about how about this hackathon, like what is that project you want to submit for it. So you can register first, and you can kind of hang out with other hackers here, like set up some ideas, brainstorm some ideas with other developers in this hackathon. And once you confirm what you want, what you actually want to submit, you can click the button here, submit a build. If you are new to the platform, you will click the button here, create a new build, type all of the information, including the names, logo, type of the project. It should be like hackathon, and the sectors in here it should be crypto, the tagline, the vision of the project, the build description. You are required to submit your TG handle just for verification of the project. And you can add your teammates, your team information, your GitHub repo. And once you have like filled out all of the required information here, you click here and you can submit a build and back. And remember, this is not finished because you just create your own project, but you have not officially applied for the hackathon. So here, you can go back, and once you finish the creation of your project, you will see a available option here, and you can select the relatively track for your project for the field hackathon. And yeah, that should be it. I believe it's quite simple and straightforward. We will add another extra tab here about with a guidebook for all of the developers, to just in case you are still confused about the process. Yeah, and I think that'll be all from my side. And I saw questions from audience say that any rough ideas about mainnet launch. Not sure, like Nick, you want to share some insights here?
Yeah, I mean, I think for us, the way that I would put that question is this year for sure, but we're just working through all the different test nets and changes. There's a lot of different spec changes that we want to get in before mainnet, just so we can kind of build the kind of applications we'd like to see. So there's a lot of changes coming, but more importantly, I think beta 4 is almost there. It's probably a few more weeks, and then we should be up with that. So that's the more short-term answer.
Sounds great. that's super excited. Yeah, and don't worry. Feel free to for all of the audience, if you have any questions during the submission time, feel free to reach out to our team. We will always be there to solve your problem. And if you want to join a hackathon, please feel free to join as soon as possible. I know there is still 1 month left, but it is always good to join early rather than late, because it can also provide judges at the end for them with a better longer time to review a project as well. So yeah, that's it. I think that'll be all. Okay. A new questions. With new SDK version and new Sway version, usually dApps breaks, how this will handle in the future?
Yeah, so right now we're looking to kind of basically streamline our release process so this doesn't happen as much. We have a lot of different libraries and concerns as we're shipping. So naturally, it's hard to get it all coordinated right for each release. But we're going to be switching to a new release process in the future where all these things will get tagged in a future release, and then that way we don't break the previous stuff. That's also going to be more long running test nets and things like that. So you should be seeing a more smoother release process probably post beta 4. So that's a quick update there. Oh, I think you muted, Chris.
Yeah, great. Cool. Let's see. Let's wait for a couple more seconds to see if there's any more questions.
Cool.
The price for each category is for every project or winners. I believe it's gonna be for the winners. Each tracks will have winners. You can find the track details on DoraHacks DoraHacks Sway Hackathon details introduction page. Yeah, but I believe the prize pool will be distributed to each tracks. Every tracks will have a couple different prices. The higher the higher you win, the more you can earn from the prize pool. Yeah, so very traditional hackathon mechanism. Yeah. If there is no more questions, I think we can wrap up here. Definitely appreciate Nick your time to join us and give such a great presentation, and also appreciate all of the audience to join us today. And I hope this opening ceremony can be useful. There will be another 2 workshops in the future about the hackathon. So if I think that will be more technical driven. So if you are developers and are interested about the Sway language, definitely I would highly recommend all of you guys to join those 2 workshops in the future as well. Should be next week. Yeah. And let's wrap up here. Hope everyone can have fun doing building with Sway and fuel blockchain network.
Awesome. Yeah, thanks everyone. Really excited. And again, one last note is thanks for eating a bit of glass with us as we ship a lot of different code over a very quick period of time. So definitely thanks for fighting it out. And yeah, super excited to see what comes of the next month and all the hacking.
Yeah, sounds great.
Awesome.
Thank you guys.
All right, thanks Chris. Thanks everyone.
Thanks. Bye guys.